third one. So we have find the equations of the tangent lines to the graph that pass through the point. So you have tangent lines, but you want that line to go through this point. This is actually a pretty difficult question. So let's start off with a tangent line. This is going to be the fact that tangent line gives you the hint, I need to find f prime of x. I'm going to do a quotient rule. The numerator derivative is 1. The denominator derivative is 1. F prime of x is equal to low d of high minus high d of low all over low, low. So let's go across actually. The top is x minus 1. And then minus x times minus, and then minus x times negative 1. So we have negative x squared plus x all over x minus 1 squared. That is negative x squared plus 2x minus 1 is over x minus 1 squared. So let me just double check that I didn't make any mistakes. And I think I did. And I'm going to actually go back and fix it. I had a feeling this didn't look correct. All right, so here is my mistake. Let's do our derivative one more time. Low d of high minus high d of low all over low, low. That looks much better. I have no idea what I did a second ago. All right, so your numerator is x minus 1 minus x over x minus 1 squared. You get negative 1 over x minus 1 squared. So that is the slope of tangent line. So now that I got my slope through the tangent line, I actually have a point. So I can go through and write y minus y1 is equal to the slope times x minus x1. The point was negative 1, 5. The slope, I don't have a value because I don't know what the slope will be, but I do have an equation I can substitute in. And so I'm substituting in the point here. This is a pretty difficult problem, realizing that the slope of the tangent line, we don't know what the value is. So I'm actually just putting the whole equation in for the slope instead of the exact number. So you end up with this ugly looking equation. I'm going to go through and add the 5 to the other side, just so I have my y by itself. So that's one equation with two unknowns. So to the right here in purple, I'm actually going to figure out if there's another equation. Well, there was at the very beginning another equation. So you can use the purple equation and the blue equation. You will do a system. And the reason why, if this is a tangent line, then the tangent line has to intersect this graph. Intersecting means that I can set the two equations equal to each other. So in black, the equation of the line, the equation of the function will intersect, and I'm going to substitute in something that looks a little bit nicer to me. Okay. Negative x plus 1 over x minus 1 squared plus 5. And I am going to decide what's the best way to solve this. The common denominator here is x minus 1 squared, so I'm going to multiply every single term, so both sides, by x minus 1 squared. So what does that look like? X minus 1 squared on this side, and then if I multiply the whole thing by x minus 1 squared, what you end up with is, on this side, the denominator cancels with one of these, so I get x minus 1 times x is equal to, this orange one would cancel both of these, so the first term, the denominator has been canceled out, but the second term I'm going to have be multiplied by the orange x minus 1 squared because it doesn't have a denominator to help cancel. So let me see how far I can get on this page. X squared minus x is equal to negative x plus 1 plus 5 times, and FOIL, x squared minus 2x plus 1. And let's try our best to get this to look as nice as possible. And all I'm doing in this step is distributing my 5. 5x squared minus 10x plus 5. And now that it's quadratic, I'm actually going to save myself some time and expect that you can set this whole guy equal to 0. You can try to factor or do quadratic formula to solve, and hopefully that will help.